Welcome dear students, we are on the CEC Gurukul lecture. We are in the series of electronic circuit and we are discussing the motors today. So up to now we have discussed the types of motors, where we discussed the two type of motors. One is AC motor and second is the DC motor. There are special type of motors are also. So the AC motor, DC motors are divided into two parts, brushed and brushless. Or here the second type is the AC motor, which are the synchronous and the asynchronous. So we are discussing the AC motors, and up to now we have discussed the synchronous motor. We are discussing the asynchronous motors. Asynchronous motors are classified into two types. One is the induction motor and second is the commutator motor. In the induction motor, that asynchronous motor that works on the principle of electromagnetic induction and between the stator and the rotor. A motor having the stator and rotor, and induction, electromagnetic induction is produced in between the stator and rotor. So here we produce a revolving magnetic flux induces a current in the rotor due to the electromagnetic induction, which produces the torque in the rotor, and that will come as a output. So it has the most electric motor. This type of motor is used in the industry. That is one type of the motor that is in the industries, and it is mainly divided into two types on the basis of its construction. One is the squirrel cage induction motor, and second is the slip ring type of induction motor. So first is the squirrel cage induction motor, where all the arrangement are in the form of the conductive ring, where what we do, the rotor such as the induction motor resembles as a squirrel cage, and it is made from the copper wires that connected at the both the end using the conductive rings to make a closed loop circuit, and there is no electric connection to the rotor, and the stator's varying magnetic field induces a current in the rotor's bar, that is the copper bars, and the induced current generates its own magnetic field in the rotor, which interacts with the stator's revolving magnetic field and tries to eliminate it by revolving it in the same direction. So it has a very simple design, it is inexpensive and more reliable, such but there is no electric connection or the commutator and brushes assembly, and it requires a less maintenance. But apart from this, there is another type of induction motor, that is the slip ring induction motor. This type of slip ring or the wound motor rotor induction motor is another type of the induction motor, where we use the rotors is made of the windings that are connected with the slip rings, and where we use the loops in the circuit, here we use the slip rings. These slip rings are used to connect the windings to the external resistors for controlling the rotor's current and hence allowing the control of the speed and the torque characteristics we can get it out. And this type of slip rings constantly slides with the brushes that requires the costly maintenance due to the mechanical wear or the tear. The construction is very complex, so it is more expensive than that of the squirrel cage motor, and that are mostly used. Again further they are divided into two, capacitor and resistor. The capacitor start induction run motors, as the name suggests, capacitor. So we use the capacitor in series with the auxiliary winding to generate the extra torque during the startup, and when it is started, then it is disconnected once the motor reaches its near synchronous speed using the centrifugal switches. You see here we are having a centrifugal switches, and the starting capacitor on the right hand side we are having. Once the motor started, then we just close the centrifugal switches. So this is one type of the capacitor start induction run motor, which work on the single phase supply, and auxiliary winding is there and main winding is there. In between these two there is a rotor that rotates starting when we start the capacitor, we arrange the capacitor in the series, and it has a two stator winding called, it is the main winding or the auxiliary winding. You see here we are having a two winding, one is the main and another is the auxiliary winding. The auxiliary winding is connected in the series with the capacitor using a centrifugal switch. When the motor starts, the current flows through both the windings, generating high starting torque. So, once the motor reaches at 70 to 80% full speed, the centrifugal switches will disconnected. The supply to the auxiliary winding. The motor as you resumes operating on the main winding and it works. And these two stator winding called the main winding and auxiliary winding, where auxiliary winding is connected in the series with the capacitor. Now the capacitor start and the capacitor run motor, and it is also a single phase induction motor where we use the two capacitors in its operation. The two capacitor starts the capacitor and run the capacitor. The start capacitor is used for only the starting the capacitor to offer the extra high starting torque, while the run capacitor is used continuously for normal operation to the run the motor. That's why its name is start capacitor and run capacitor. And the starting capacitor is connected or disconnected using a centrifugal switches. So here see in the diagram you will see apart from the single, here we are using the two capacitors. One is running, right hand side you see one is the running capacitor and second is the starting capacitor, and this starting capacitor is connected with the centrifugal switch. And again we are having a two windings, auxiliary and the main winding, and this we are using the single phase supply. So this is a capacitor start, capacitor run motor, and it works. Now when the motor starts, both the capacitors are connected, offering high starting torque to the rotor. As the rotor speeds pick up, the switch disconnects the starting capacitor. So such motor uses both the main and auxiliary winding continuously, which is why its operation is smoother than the motor running on the main winding. Only such a capacitor run motor. So the another type of motor is the first is the induction motor, now next is the commutator motor. This type of the AC motor that utilize the commutator and the brushes to assemble the motor, and we supply the power supply to its rotor. Such electric motors have wound type rotors, and these are further divided into AC series motor. As name suggests, electric has the two types of the winding, the starting winding and the field winding, and the rotor winding or the that is the rotor winding, and another type of winding is here. The both the windings here you see on the screen, that both the winding are connected in the series, and it is known as the series wound motor. And this it is also known as a universal motor due to its capability to run both the AC and DC supply as well. That's why you see AC source we can use or the DC source we can use in this type of capacity, this type of motors. And yeah, and this type of field winding carry the same amount of the current as the rotor winding. The brushes that supply the current to the windings that through the commutator shorts the windings and acts as a shorted at its shorted transformer here we use, and the brush generates the arc that decreases with the increase in the speed. The here we see on the screen, this is a compensating winding and is added in the stator beside the field windings. So here we use the compensating winding. You see on the right hand side, you see on the yellow mark are the compensating winding. Here we the field winding on the both the side, and now this rotor are under the field winding as well as the compensating winding, and it is connected, as we see that we eliminate or mitigate the arcing problem here. Another type of motor is a repulsion motor. That type of repulsion motor, that is the AC single phase motor, where the AC input is only applied to the field or the stator winding. This type of winding are connected to the commutator, and there is a no electric connection between the field winding and the armature winding. And this is the, you see here, there is a AC supply. This is a repulsion type of motor where you use the shorted brush. You see on the screen there is a brush, and between the rotor that is used, there is a coil which is connected with this type of the short brushes. Now you see, and these brushes are configured in the such a way that it can be moved to change the angle with respect to an imaginary stator axis, and this motor can be stopped, start and reverse by changing the angle of the brushes, and also vary with the speed of the motor. You see here that we can change the position, we can change the speed of the motor in this type of repulsion motor. Now as the rotor is shorted using the brushes to form a loop, this current is induced when alternating current flows in the field winding. So this induced current flowing in the rotor winding generates its own magnetic field, and that magnetic field produces the torque, and this direction of the magnetic field depends upon the brush's angle, and the magnetic field interacts with the stator's field and the rotors reacts accordingly. For the rotation of the brushes are slightly rotate at the 20 degree at either the direction to the rotor or direction to the rotor, or at the direction of the stator. So placing the brushes at 90 degrees or 180 or 0 degree would stop the motor. So varying the angle increases or decreases the repulsion between the stator and the rotor magnetic field, the rotor's speed varies, and that's why it is a asynchronous. As the speed vary, as the angle changes, as the angle increases or decreases, the repulsion between the stator and rotor magnetic field and rotor speeds is varying now. So then the starting torque can also be controlled by varying the angle of the brushes, providing the maximum starting torque at 45 degree. It means we keep these brushes at approximately at the 45 degree to get the better output. This motor was used for traction due to its superior speed regulation, but it has been suppressed by other traction motors. And in this case, another type of motor is a repulsion start induction run motor. It means the starting we we do starting with this type of motor with the repulsion and run through the induction. The repulsion induction motor are also known as the repulsion start induction run motor. That is this type of motor is the modified version of the squirrel case that uses the high starting torque feature. Repulsion motor normally runs as a squirrel case induction motor, and there is a special mechanism for the starting and running this type of motor. During the motor starts, the pair of the shorted brush is connected with the commutator in an particular angle, such as in the repulsion motor. Once the motor picks up the speed, the mechanics lift the brushes and connects to the bar together by shorting the commutator to form a squirrel cage rotor. The motor resumes operation as the induction motor. The benefit of the repulsion is that it starts offering the 5 and 6 times high starting torque as compared to the other induction motor. So the brushes also have the longer lifespan as it uses for the starting the motor, and therefore these electric motors have high mechanical life and require the less maintenance. Now we will discuss the one by one what is the working principle of the AC motor. The fundamental work of the motor is convert the convert the electric current into the electric current into the mechanical field. So the fundamental operation of an AC motor depends upon the principle of magnetism. As we are discussing that when we electric supply, when we apply the induction, when we apply the rotation in between the between the coil, rotor and rotor, so what it produces the torque. So how it produces a torque? Because it works on the principle of magnetism. So simple AC motor contains a coil of wire, two fixed magnet surrounding a shaft. If we talk about the construction of a motor, then we can simply say that it's working on the principle of the magnetism. Number 2, the simple AC motor contains a coil of wires that is fixed in between the two magnetic surrounded a shaft. When an electric charge applies to the coil of the wire, it becomes an electromagnet, and this electromagnet generates a magnetic field. Means a AC motor contains a coil of wire and two fixed magnet which is surrounded by a shaft, and this magnet works as a electromagnet. This electromagnet generates an electric magnetic field. So inside a stator there is a solid metal axle, a loop of wire, a coil, a squirrel cage made of metal bars and some other freely rotating metal part that can conduct electricity. In an AC motor, we can send the power to the outer coil that makes up the stator, and this coil energizes in the pair in the sequence, producing a magnetic field that rotates around the outside of the motor. Number 4, the number third, the motor suspended inside the magnetic field. The rotor suspended inside the magnetic field. The magnetic field is constantly changing due to the rotation, as and according to the law of electromagnetism, the magnetic field produces an electric current inside the rotor, and if the conductor is a ring or a wire, this current flows around in it a loop. So now the electric current we generates will flow around in the form of a loop. If the conductor is simply a solid piece of the metal, eddy current flows around its instead. So the rotor, here we can say the magnetic field is constantly changing due to the rotation according to the law of electromagnetism. So magnetic field produces an electric current inside the rotor, and this electric current flows around in the form of loop, as we are using the conductor in the form of the ring. So if the conductor is simply a solid piece or a metal, then the eddy current flow around it instead of the uh, loop. So induced current produces its own magnetic field according to the another law of the electromagnetism. So the rotating magnetic field by rotating as well simply describes when the magnets interact, the shaft and the coil of the wire begins to rotate, which operates the motor. Means that current magnetic field which produced through the electromagnetism which rotates the shaft, and when the magnet interact, the shaft and the coil of the wire begins to rotate, and which operates the motor. So in this manner a AC motor works. Now we will discuss the DC motor. Next, another type of motor is the DC motor. AC motor where we use the alternate current, and the DC motor where we use the direct current. There is no phase in the direct current, there is why DC electric motor only uses the two wires to run. So DC motor is another main type of electrical motor that only runs on the DC or the direct current. There are no phase in this type of DC motor. In the direct in the and DC motor only uses two wires to run. There so there are the first motors to be invented of the DC motor. There it is easier to control its speed by only varying the supply voltage in the DC motor. And moreover, this type of DC motor offers simple starting, simple stopping, accelerating and reversing mechanism is easy in the DC motor. The installation cost of DC motor is very cheap, but they do require the maintenance whose cost increases significantly with increasing the size and power of the motor. And what is the basic principle of the DC motor? It works on the Fleming's left hand rule. A current carrying conductor inside a magnetic field experiences a force of thrust mutually perpendicular to the each other. That is the Fleming left rule. This DC motor classified into the further classified into the brushed DC motor, brushless DC motor, coreless or ironless DC motor. So we discuss one by one what is a brushed DC motor and which is a brushless DC motor. In the brushed DC motor, uh, as the name suggests, brushed means these type of electric motors have the brushes and the commutators. So in the brushes DC motor we use the brushes as well as the commutators. They are used for connecting a stationary circuit with a rotating circuit. We use the commutator or the brush to connect the stationary circuit and the rotating circuit. In such a case, the rotor winding of the motor is energized through the conductive brushes. Conductive brushes play a very important role in the rotation. What are the disadvantages of this type of brushless motor is that it requires the frequent maintenance due to continuous sliding of the brushes. The spark generated between them, and however they are quite simple in design and they are inexpensive. This is the brush type of motor. You see here on the right hand side you can see the brushes commutator are in between the DC supply and winding, both the winding are there, and here you see winding and in between that brushes are used. And this type of brush electric motors are divided into three parts. One is the separately excited motors, second is the self excited DC motors, and third is the permanent magnet motor. What is a separately excited DC motor? Which has a separate excitation. The excitation refers to the energizing of the field winding, also known as the stator's winding. Means we use the DC motor has a separate excitation. Both the windings, that is electric and armature winding, are connected with a separate power supply. You see on the screen that in such type of configuration we can independently strengthen the magnetic field by increasing the DC excitation without changing the alternate armature current. You see here the right hand side, you see here the we can see the separately these two are the conducting to each other. So this type of configuration independently strengthen the magnetic field by increasing the DC excitation. Now this is the main distinguishing point, that is the armature current does not flow through the field winding. And next type of motor is the self-excited DC motor. This self-excited, as name suggests, that this type of winding is electrically connected with an armature windings, and this a single power source energizes both the windings. Therefore, it does not require the separate excitation source. So, in the previous we require the excitation source in that one. However, the field winding can be connected in the series, parallel and partially series configuration, or the partially parallel. So, there is a self excited DC motors which are further classified: series wound, shunt wound and the compound wound. This is the series wound, where we just wound the DC motor. The field winding is connected in the series with the armature winding, and here there is a current flowing through the field winding, the same as the current through the armature. Now you see another type. The speed of this type of motor varies with varying the load connected to the motors. Another is a shunt type of wound, and this type of such type of winding is known as a where we DC motors have the field winding connected in the parallel with the armature winding, and it allows a full terminal voltage. And this is the compound wound. In the compound wound features both the series wound and the shunt wound DC motors are there. It combines both the parallel combination as well as the series combination of the fielder and the armature winding. And due to the combination of these, it's again further divided into cumulative as well as the differentially compound. And this type of and both the type of compounds motors can be short shunt, long shunt, depending on the arrangement of the windings, and the output and the torque produced as per the requirement. Thank you very much.